chapter 3.1 notes, getting into chapter 3 with our exponent stuff. If you get on Moodle, like hopefully you're supposed to, there already is some kind of helpful videos that I didn't make. Okay, and maybe you want to hear a different voice, like some of our Khan Academy, in terms of exponent laws, of just going through those. They're only like 8 or 9 minutes long. So if you get on there, you just want a little extra kind of support, that'd be a good thing to look at. Okay, so again, use Moodle. I need to do a better job pushing it for you guys. We might have a Moodle quiz this chapter on there. We have to go on Moodle and take a quiz, like a formative quiz. But anyways, we'll get to that later. However, so this is kind of weird. I swear, like when you're a math teacher, the problems you make up off the top of your head, they come up somewhere else. But 2's and 2's, I don't know how that happens. It's weird. Okay, but anyway, it says write in exponential form. So we just did this. So it is 1, 2, 3, 4, 5. How many do I have? I had 5. That's just creepy. Okay, all right. So that's 2 to the 5th. Then you evaluate the power 2 to the 5th. Okay, that's going to be 32. So evaluate means give the value. And we're at 32, no problem. Okay. Write repeated multiplication in exponential form. So then evaluate. So 1, 2, 3, 4 cubed. That evaluated is what? So 4 times 4 is 16, times 4, 64. Good. Okay, so write this one is the exponent, 10 to the 4th. Our powers of 10s just mean how many zeros. So 1, 2, 3, 4. It's 10,000. Okay, because 10 times 10 is 100, times 10 is 1,000, times 10 again is 10,000. Okay. All right, pretty straightforward. All right, so then evaluate each power. Read as 4 squared, 2 cubed, 3 to the 6th power. That's kind of how you read them. Just in terms of why it's called squared, that comes from applied problems of area. When you're finding area of a square, you go length times width, right? Which is side times side. So we say side squared because it's the same number times the same number. Now with cubes, why are we calling that 2 cubed? Because we're talking about a 3-dimensional figure. Okay, if you're finding the volume of a cube, it's all 3 of its sides. And in a cube, all the sides are what? Like a square, they're all equal. Okay, so that's why it's 3 cubed. All right, so just want to understand why. I wouldn't know that when I was your age. I just thought it was just a weird thing to call it. So you guys get some sense of where it came from. Okay, so 4 squared, we're evaluating at 16, no problem. In terms, again, you don't need to know this. I'm just saying it comes from this times this gives you 16 for a square. That's where it comes from, okay? And I'll do my best to draw a cube here, but I'm not a very good artist. Okay, so then if we have a cube, it's 2 times 2 and then times 2. 2 times 2 times 2 is 2 cubed. 2 cubed is 8. So the volume of this cube would be 8. What's that? Yeah, exactly. Base times length times width times height is what they say, but yeah, base. You also can just call it base times height if you want. Okay, and then 3 to the 6th. Okay, so that's going to be a little bigger number, so probably need a calculator for that one. But 3 times 3 is what? That's 9. So that's the 2. And then times 3 is 27. You got it? 81, 243, 729. Okay, thank you. So 729. Thanks, Luke. Again, now if you're saying, I assume you know how to use your calculator, but if you don't, you need to find on your scientific calculators, they usually have a caret. Yeah, Luke. Okay. Okay. They usually have a caret. What I mean by caret is on your calculators, they usually have this button here. That's the exponent button for numbers bigger than 2. Okay? So if you're in your calculator and you want to do 3 to the 6th, you put a 3 in, you put a caret in, and then you put a 6 in. And that means 3 to the 6th. If you need help finding it on yours, I can help you find it, but a lot of those carets on the right side. Okay? Yeah, I think yours is on the right side. Yep. Okay? If you need help trying to figure out how to use your exponent on your calculator, I can help you whenever we have time. All right. Keep on going here. Complete the chart. So we have 2 to the 4th. 2 times 2 times 2 is 16. 6 squared. Repeated multiplication is 6 times 6, 36, no problem. Okay, Jade, how would you write 3 to the 4th?
3 times 3 times 3.
Okay, and do you know what that is? 9, 20. What's 27 times 3?
81.
81. Okay, so the reason I asked you that is because that's a mental math thing. Okay, here's how you do it. This is like for your guys' math minutes. 3 times 27 is fairly simple. What is 3 times 20? 60. What's 3 times 7? 60 and 21. Put those together pretty easily, can't you? That's all kind of mental math. So again, I did 3 times 20. I'm just going to talk about this real quick because this is important to me. Break this up to 3 times 20 plus 3 times 7. 60, 21, 81. Because we can add 10s fairly easy, right? So multiply those fairly easy. So that kind of, whenever you're doing hard numbers, multiply by the biggest possible 10 you can. Okay? The biggest possible one for 27 is 20. Anyways, good. And thanks, Jack. 81. All right. 5 cubed, 5 times 5 times 5, and you get 125. All right, and then look what they're going for example 3, what we already talked about in the warm-up. They're really trying to sell you on the negative brackets versus not negative brackets and the difference. Okay? So we're going through this. You understand the difference between these two is the main point. So evaluate each as a power. So if you're evaluating each as a power, you'll see negative 2 to the 4th. Okay, another thing we want to look at is going to be like this. How many negatives are there? 4. So your answer is going to be positive because you have an even amount, so they're going to cancel out. Okay, that's an important concept to understand, that if I do a negative to an even power, it's going to come out positive. Does that make sense? This is another, like a little smaller example. If I have 3 squared, that's 9. If I have negative 3 squared, that's also 9. Because they're both even powers, they both end up being positive. Okay, so here is 16. Okay, because negative 2 times a negative 2 is a positive 4, times a negative 2 is a negative 8, times a negative 2 is a positive 16. Yeah. Right, if it's negative 2 cubed, we'd be at negative 8. And that's because we have a pair, these two, but then we have one guy by himself that's going to make it all negative. You guys got that? Very good questions. These are the questions you guys need to ask. Those are very good concepts to get ingrained in your mind. Okay, I get frustrated when I ask my math 20s, like, it's the odd power, is it positive or negative? They're like, well, I'm not sure. Well, it's negative. Okay, this negative is on its own. So it's going to be 2, 2, and 2. So no matter what, it's going to be a negative answer. So that's a negative 16. I know it's to the 4th, but it's not in the bracket. Okay, so that 4th is only on the 2. It's not on the negative. Again, that's the biggest thing we miss, the biggest thing we struggle with. Okay? This one here, negative 4 cubed. So then back to what Nolan was saying, that's an odd with a negative. So we expect our answer to be negative. Be negative 64. Whoops. This one's kind of tricky. So it's a negative 5 to the 6th, which would be positive, but then it has a negative outside, which makes it negative. So we have a negative here. Then we're going to write negative 5, negative 5. 1, 2, 3, 4, 5, 6. And we're going to multiply that. You're going to see that these two will be a positive, these two will be a positive, and these two will be a positive. So we end up having a positive, but then he says, nope, it's negative. Okay? What's 5 to the 6th, guys? Gals? Luke, you have it already?
15,625.
Thank you, sir. Yeah, did that in your head? Good job. Okay? And guys, I know you might be bored. This might be super easy. That's good. Let's set a good foundation. It's going to get harder as usual. All right, this is the last page. Give one reason why negative 5 squared and negative 5 squared, the brackets, is different without. Aiden?
Because one's positive and one's negative.
Good. So the answers are different. So we'll say answers are different. Okay. Anybody have anything to add?
Negative 5 squared is negative 5 squared. You have negative without the
Okay, so the brackets, I'd say brackets, and Luke, I'll let you answer another one in a second. Brackets is squaring the -5. Without brackets is squaring just the 5. Oh. Okay, just the 5 is getting squared without brackets. Okay. All right, and then why are they similar, Luke? What would you say? What's one reason they're similar?
Because both of the numbers are being squared.
Yeah, both are being squared. It's about all, right? Let me ask you this. Somebody who hasn't spoke yet. What is the base of each of these? So what's the base? So you guys both said something. Anybody? Cato, what's the base of these two? Yep. -5 with brackets, and then what's this one's base?
5 times 5.
Yeah, just 5. So this one's base is -5. This one's base is just 5. Another difference. Okay. All right. Cool. Both are being squared. All right, and then we'll finish this up. All right. So Duffy, what's this one? What's a? Yep. No problem. Or we'll come back to you. Connor, what's this one? Nope. Nope. 9. -3 times -3, right? But to be fair to Connor, like that's a very common thing. People go, oh, cool, 3 times 2. Okay, it's not. Remember, it's times itself. It's times itself. All right, good. How about -3 to the 5th? Sure, you got that one, Jack?
243.
243, is it positive or negative? No, it's going to be negative. It's an odd. Yeah, okay, it's an odd exponent. There you go. It's an odd exponent. Let's see here. Tor, how about 3 here? Good, -9, because the negative's outside the brackets, and then we'll go ahead and just, so if this, this is also going to be what? Yeah, these are the same, all right? Because this one ended up being negative, this one says it's going to be negative. Okay? Say it. No, you keep your notes. Your notes are for you. Okay? So, yeah, hold on just one second.